In this video, we will talk about finding the component form and the magnitude of a vector given its graph. First of all, component form. A vector has a starting point, and then it travels in a given direction for a certain distance. So just like we think of x's and y's, the horizontal change and the vertical change, that's how we will write the component form of a vector. So if I go from the starting point to the end of the vector, first of all, what is the change in x? In other words, as I travel horizontally, how many units do I move? So let's see, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I moved 11 units to the right, so that's going to be positive 11. And then I would have to move 2 units down, so that's going to be negative 2. So this would be the component form of this vector. It's the horizontal change and then the vertical change. Now the magnitude is the length of the vector. It's just the length of the hypotenuse of this right triangle. So we can simply do the Pythagorean theorem. And in the Pythagorean theorem, we would say the c squared is equal to a squared plus b squared. All right, so we would say that c squared is equal to 11 squared plus 2 squared. All right, or even if I said negative 2 squared, it would still be the same thing. But the next thing I would do is I would take the square root of both sides, all right, to get c by itself. So basically, there's no reason why we can't just go straight to this. So if you want the magnitude of a vector, it's just going to be, or if you have, say if you have vector AB, the magnitude will simply be the square root of a squared plus b squared. So that's what I'm doing here. So this is going to be the square root of 121 plus 4. Okay, so that's going to be the square root of 125. Now, the creators of this worksheet have called this vector Q. So let's use our notation. If I want to talk about the magnitude of vector Q, then I put these symbols around it like absolute value. But in the context of vectors, it means the magnitude or length of vector Q. So that's it. We found the component form, and now we found the magnitude. Except for wait, we should simplify this down. 25 divides evenly into 125, so this is the same thing as 25 times 5. And so the square root of 25 is 5. So this is going to be 5 radical 5. So again, the magnitude of vector Q is equal to 5 radical 5. So this is the way we should write it. So looking at problem number 2, the component form, I would have to go 3 units to the right, and I would have to go 7 units up. So this would be the component form. Now the magnitude of vector z is going to equal the square root of 3 squared plus 7 squared. All right, again, it's really just the Pythagorean theorem. So the magnitude of vector z is going to equal the square root of 9 plus 49. So that is the square root of 58. And this doesn't simplify, so that's it. So we have the magnitude and we have the component form. Okay? All right, for problem number 3, we're supposed to use the vector in problem number 1 and find component form, but we are multiplying by some things. This is called multiplying by a scalar. Let me just add this vocabulary in. When you're multiplying by a number, you're multiplying a vector by a scalar. And let's see. The vector was 11 comma negative 2. That was the vector that we had. So that means this is 3 times 11 comma negative 2. So you can just multiply each of the components by 3. So that's why we're going to have 33 comma negative 6. Okay, and here we have negative 11 comma negative 2, which is just like having negative 1 times 11 comma negative 2. So that's going to be the vector negative 11 comma positive 2. All right, just multiplying by a scalar. Just multiply the components. All right, and here we have 5 times vector q. So that's just going to be 55 comma negative 10. Very simple. Okay, and if I have negative 2 times vector q, that's going to give us negative 22 comma positive 4. All right, number 4 looks like more of the same. Vector z is the vector that we did in problem number 2, and it was 3 comma 7. All right, so we're using the vector 3 comma 7. All right, so 10z is 10 times 3 comma 7. So that'll just be 30 comma 70. Negative z will just be negative 3 comma 7, or negative 1 times 3 comma 7. So that'll be negative 3 comma negative 7. All right, and then we have negative 6 times vector 3 comma 7. So that will be negative 18 comma negative 42. And then we have 2 times the vector 3 comma 7. And that will be the vector 6 comma 14. For number 5, we are going to draw each new vector from the initial point, or tail, of the original vector. Now, vector q here is the vector 11 comma negative 2, as you can see. So negative q is going to be the vector negative 11 comma positive 2. So that means it's going to be, starting from here, as we said, it should be 11 to the left of here and 2 up. So I'm going to count, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and up 2. So this is where the vector should end. Now I'm going to try using the drawing tool, the draw arrow tool. So I'm going to go into the draw menu, pick the arrow, okay, and go like this. Boom. So as you can see, the vector negative q is going to go in the exact opposite direction of vector q. Okay, and maybe I can label this as well as the vector negative q. All right, then for part B, we have the vector 2q. All right, so once again, if vector q was 11 comma negative 2. Then 2q is going to be 22 comma negative 4. Okay, I'm going to need more space for this, so I might have to zoom out or something. Here, I've also cut and pasted a copy of vector q to show you that if I put two of them end to end, then that's going to be the same as 2q. Alright, so this would be, if I make one vector that's this length, then that should be 22 comma negative 4 starting from the endpoint as before. So here's vector 2q shown in purple, stretching from the initial point all the way to the end, the terminal point over here. And as you can see, it is 22 over and 4 down from the initial point. Now for part C, I'm supposed to draw negative vector z. Alright, so here's an image of vector z. And a vector z is over 3 and up 7. So vector z is the vector 3 comma 7. So of course negative z is going to be negative 3 comma negative 7. So once I draw this, this should wind up going in the exact opposite direction. So let's see, if I go left 3 and down 7, I'm going to land right here. I'm going to use my draw vector tool, okay, to draw from this terminal, from the initial point to the terminal point. Okay, so here is negative z drawn in purple. Okay, notice that it goes in the exact opposite direction of vector z. Okay, and then for part D, I'm supposed to draw negative 2z. So again, keep in mind that vector z is the point, is the vector 3 comma 7. So the vector negative 2z is going to be negative 6 comma negative 14. Alright, so visually what you should expect to see, because of the negative, it's going to go in the opposite direction. Because it's negative 2, it should be twice as long. So we're expecting to see a vector that is twice as long, but in the opposite direction. So let's see what happens as I count negative 6. So from the initial point, I'm going to go to the left 6, so that's 1, 2, 3, 4, 5, 6, and then negative 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Alright, it's almost off camera. Okay, so there's my terminal point. So I'm going to go ahead and draw this vector. Okay, and as I mentioned before, notice that it goes in the opposite direction, but twice as long as the original vector z. So this would be the vector negative 2z. Okay, problem number 6. Problem number 6 will continually refer back to these two vectors, vector A and vector B. Now first we are supposed to find the magnitude of each vector, and the magnitude of a vector is just the length of the vector. So with your view set to 100% zoom, measure this with your ruler in centimeters. Just take a ruler, put it on the screen, and measure it. Make sure you're at 100% zoom. So I've done that, and vector A has a magnitude of about 2.4 centimeters. This is the symbol for the magnitude of vector A, these absolute value type symbols. So the magnitude of vector A is about 2.4 centimeters. And I have also measured vector B, and this has a length or magnitude of about 1.3 centimeters. Okay, now to estimate the direction in degrees, in each case we are just measuring the angle. So I can't show this on the screen, but you need to take a protractor and just measure this angle. Now I've done that, and for vector A, this angle is about 75 degrees. For vector B, I measured this angle with my protractor, and that was about 60 degrees. But for the direction of vector B, you have to measure all the way from the positive x-axis, or east, due east. So that's of course 180. So if I take 180 plus 60, that's a total of 240. So vector B has a direction of 240 degrees. Now here, for part C, we are supposed to sketch 2A, 2 times A. So we're looking for a vector that is double the length of A, headed in the same direction. So to illustrate this, I'm going to click on Draw, choose my arrow tool, and first I'm going to just copy the original vector, which looks about like that. Now I'm going to copy and paste this, Control C, Control V. Now I've duplicated it. So now if I were to put this end to end, this should be the length of 2A in the correct direction. Okay, so now I'm going to draw one more vector, just going straight from beginning to end of this whole thing. Alright, but this time I'm going to change the color to purple. Alright, so there you go. This purple vector that I've drawn should be 2A. Now, looking at part D, we're supposed to sketch negative vector B. That's the opposite of vector B. So we're looking for a vector that's the same length but going in the opposite direction. So how am I going to do that? Again, I'm going to click on Draw and choose my arrow drawing tool. Alright, so far I've just copied the original vector. Now, to make it go in the opposite direction, I am going to click on Draw again, and I'm choosing Rotate. So I'm going to rotate this 90 degrees. Okay, so that's 90 degrees to the right. And now I'm just going to rotate another 90 degrees. So now I've rotated 180 degrees total. So this should now be going in the exact opposite direction. Okay, so now I have illustrated the opposite of vector B, negative B. Okay, similarly for part E, as I do 3 times vector A. So here's vector A. Better leave myself some space because 3 times A should be triple this length in the same direction. So again, I'm going to choose Draw, and I'm going to choose my Draw Arrow tool. First, I'm going to copy the identical arrow, the identical vector. Let me change this back to black for a moment, because this is not my final answer. Okay, so I've copied it. So now I am going to Control C, Control V, I've duplicated it. Alright, so if I put these end to end, so far that's 2a. If I put another one end to end, now I've got 3a. Alright, so if I just take one vector representing all three of these, that should be what vector 3a looks like. So I'm just going to go from beginning to end of all three. Alright, and this time I'm going to click on it to activate the properties and change this to purple and make it a little bit bigger so it stands out. Alright, so there you go. The purple vector is vector 3a. Okay, so what do you think the vector negative 4b is going to look like if this is vector b? Because it's negative, it should be heading in the opposite direction of this. So it should be going into the first quadrant, but it should be 4 times as long. So I need a vector that's in the opposite direction, but 4 times as long. So I'm going to click on draw, pick my arrow tool, and first of all I'm going to draw myself a little vector, just duplicating vector b. Now, to make it go in the opposite direction, I'm going to rotate it. So I'm going to click on draw, then I'm going to choose rotate 90 degrees. And I'm going to do that one more time. Rotate 90 degrees. So now I have vector b, but I'm heading in the opposite direction. So this is vector negative b so far. So if I want negative 4b, I need 4 times this long. So I'm just going to duplicate this, alright, copy and paste. Alright, now I've got negative 2b. Alright, I'm going to paste again. Now I've got negative 3b. And I'm going to paste again. Now I've got negative 4b. So if I had one vector that was doing this, it would be vector negative 4b. So I'm just going to sort of keep note that this is the length of my vector. Okay, and this is where it hits. So that I'm actually going to go back and erase all of these. And I'm going to draw myself a new vector. Okay. But now I know that it will have the correct direction and length. And there it is. Let's see, can I erase my little guide points without? Perfect. So this is a nice sketch of the vector negative 4b. The negative put it in the opposite direction, and the 4 made it 4 times as long. Alright, that's going to do it for this video. I hope it was helpful, and I look forward to seeing you on the next video.